Hello and welcome to the last class on coordination compounds before puja vacation. We'll be also breaking for about a week. We'll be resuming our program after 13th of this month. I will be notifying both in Zoom as well as in the website, theuranium.org. Guys, if you are benefiting from the program, before we start, don't hesitate to subscribe to my channel, and also uh, do not hesitate to hit the like button. So yesterday was not my day. It was Omblan's day, who hijacked the class. It is for me, he could hijack the class. Such a simple thing. He even did not answer the question after spending such a long time. Amblan did correctly answer this, that there is a plane of symmetry passing vertically in the east-west direction, not in the north-south direction. So I was really stupefied when such a simple question was raised by Krishna. This is such a simple question. Any XYZ, I am showing you how ridiculous it is for um, guys like you who could not detect. Amlan was also stupefied when I didn't accept his proposal. He also saw there is no plane of symmetry. He didn't persist on his answer. So we'll be winding up the total stereoisomerism topic. And we had seen in this type M A3B3 fact more M A3B2C, there is one cis and two one pack and two Mars. Actually, I was verifying out of the two Mars, one is really a cis. Therefore, it is not wise to say Mer as trans always, because see, this BB, they are close to each other. Here, BB, they are opposite to each other. So we can also call this another cis. But when all are the cis, that is optically. So nothing is uh, here, nothing is optical active here. And we were not debating on this. That was crystal clear to us, that none of them is chiral. One fact, two Mars. And and why this is not chiral? Where is the plane of symmetry or center of symmetry? Or hello, welcome, Hulak.
ସେ ପ୍ଲେନ୍ ଟା ଏ ବି କଣ୍ଟେନ୍ କରିକିନା ପାସ୍ କରିବ ନର୍ଥ ସାଉଥ ଡାଇରେକ୍ସନ।
This is B, this is C.
ସରି ସାର୍ सर ए सी कंटेन करिक ना पास करियो सर ए और बी बी मझिरे डायगोनल टाइप
yes ଏଟା ଆ ଭିତରେ
ଆଜ୍ଞା सर यस सर
बट एटा ए दिस इज सी रहउची
सर ए से प्लेन टा ए सी कंटेन करियो ना
हां प्लेन टा ए और सी को एटा ए सी
नो सर डायगोनल रे ए सी
ए सी हां
यस सर
कोबड दे जीवो
सर ए और बी बी मझिरे जो
एई मझिरे
यस सर
can you see other guys can you realize it is really a chiral and all are chiral because in the list we have in the table that we have done in our class you see in the table that we have done it is a a3 b2c we have one fact 2 mer and no enantiomers so 3 but only case where there are 3 mers facial is optically active ma3 bc type but this has no dissymmetry all are symmetric
सर ये फैक्ट रे जदि ए बी बी मध्य जदि पास करिवो प्लेन ऑफ सिमेट्री रास्ता ताले एई पटे ए रे जाउछ एई पटे सी रह जाउछ
अरे तुम
एटा
आंसर
तो
कहूच
कंफ्यूजन
ना प्रश्न पचारुच यू हैव टू बी वेरी पर्टिकुलर अबाउट इट ए
सर
साधारण जिंस
पचार
जदि न धरे हां प्रश्न
यस सर
सब बेले तो प्रश्न always you ask question but never try to answer questions only when I commit some silly mistakes some error slip of my pen then you detect it but some intelligent not this is not intelligent at all to find this 1a b a b c and we have to find either I or sigma sn is not possibility so if we cannot find and prove that this is a symmetrical molecule is not dissymmetric then what we have studied what are the which plane once again tell me Amlan
सर ट्रांसपोजिशन जो ए और सी अछंदी से प्लेन टा ताको कंटेन करिवो सर आउ दीटा ए मझिरु पास करिवो दीटा ए और दीटा बी मझिरु
ए dita a और dita b ए
ये सर ता मझिरु
किंतु एटा कंटेन करिवो
ये सर
कोन अप डाउन जीवो सेटा बिलो द प्लेन ऑफ द पेपर एंड अपवर्ड्स जीवो ना नहीं वर्टिकल जीवो या मझिरे जीवो, right?
Yes, sir.
And it will carry A and C, right?
Yes, sir.
So that कार reflection कार कोटा हो, B रो reflection हो, and A रो reflection हो, right? Yes.
Yes.
Yes. The plane will pass through, will contain A and C. A and C will be sitting on the plane, and that plane will be going in between this AA and BB. Therefore, I told you to have a model and then see if you can realize or not. In this way, you can also find out the plane of symmetry in all these cases. And if not, you can find I. But here you will find plane of symmetry. And we had also discussed A3, BCD, where 1 FAC and 3 merge. And FAC is the symmetric, having one DL pair. Capital A whole to A2, you have one cis and one trans. Cis is optically active. Capital A whole to AB, similar. Cis and trans, cis is optically active. Then only one bidentate ligand of identical donor AA, small a to B2, one cis and two trans. The cis one is optically active. So total 3 plus 1, 4. And A to BC, there we were struggling. How ridiculous. This one we were struggling, or this one? Sorry. This one we were struggling. And how simple it is. This one is very simple. This cis1 and cis2 both are disymmetric. So 4 plus 2, 6. Trans are achiral. But A3B has no optical isomerism. And we struggled for about 5-10 minutes we spent, and no one could show me that the plane is going in this manner. How? How? How
Sir,
the
up
plane is
and
going?
down will.
Huh? North, south, na east, west?
East, west.
East, west. But that's a plane. That plane will carry A and B. A and B will be sitting on the plane, and they will be passing east, west like this, but vertical. So that this is the reflection of this, this is the reflection of this. So this is meso or optically inactive. So there is no optical active form. Facial and mer, they are all inactive. And we have also seen glycinato type, both the cis and trans are optical active. And A2, B2, C2 type has the 5 geometrical isomers, out of which the cis is optical active. So 5 plus 1, 6. And we have seen MA2, B2, CD. Have you written this? Have you written this or not? Show me the
Yes, sir.
last. Yes. Last. A3B. Here we were struggling. Hello and welcome those who are watching from the YouTube directly. This is the last class, and keep patience till the end of the class, so that we'll be revising the tabular form, because that will be very, very essential for your examination, particularly if you are an IIT aspirant or need a higher position. So it will be required. Then capital AB whole 3 glycinato type, 4 A2B2C2 we have seen, A2B2C, A2B2CD, yes, 6 plus 3, 6 plus 2, I'm sorry, 6 plus 2, 8. MA2BCD, 9 plus 6, 15. MABCDF, 15 plus 15, 30. So we were doing. Today, I was really trying to reduce whether I'm really getting for A2, B2, CD, I'm really getting 6 GIs or not. You will be surprised if you write all the 15 forms for M, A, B, C, D, E, F, and you write M, A2, B2, CD as M, A2, C2, leave B. Since you've written C2, then leave D, EF, M, A2, C2, EF. Write A for B and C for D. You will find repetitions and repetitions will come, and we will be taking one and reject the repetitions. You will find you are reduced with 6. Then if you draw all the 6 forms opposite, each pair, the members are opposite to each other. That is the presumption that we have considered in the Bayer's method. And you keep it, and you will find out of the 6, 3 of them will be chiral, will be dissymmetric. So 6 plus 3, 8. Similarly, for M, A2, B, C, D, E, you reduce the A, B, C, D, E, F as M, A2, then leave B. Hence, C, D, E, F, leave B for A. M, A, 2, C, D, E, F, make it C, D, E, F, and all in these 15 forms, write B for A. Simply B, wherever you find B, write A, because you have not taken B, B is same as A. So you will reduce the 15 forms to 9 forms, out of which when you write, you will find 6 are chiral. So 9, 6, 15. And ABCDF we have already done. And you will find all the 15 forms are chiral, and so 30. So let's start today's program to finish stereoisomerism. And then revise, because we are going in a very deep-rooted manner. So far, in none of the batches, I have gone to this extent as I have done in this batch. Now, we shall be doing, what is the number, Udit? What is the number in octahedral complex?
15.
15.
RS, you are late. This is 16.
Yes, sir.
We are doing GIOI, not GI. 16 M AA whole to A2. This we have not done. Yes, we have done this. No. AB whole 2. This we have done. AB glycinato type whole 2. AB whole 2, A2. This will have total 5 CIs, out of which cis is 3 and trans is 2. And all the cis as DL pair. So 5 plus 3, total 8. It can be, example will be diglycinato or bisglycinato dichloro. This. So I am avoiding, because I will be giving you today all the corrected file. There were a little correction that I have made. I will tell you where. I am showing you the GI file. This is MAB2 A2. Here the correction I have made. I wrote, I don't know what I wrote, maybe 2. 5 GIs, and 3 of which show OI, cis 3, trans 2, and all the cis are optically active, dissymmetric. So 5 plus 3, 8. The example I have shown in the OI file. Some examples I have Where is the OI file? Yes, it is here. Here, I have given the example AB is here. AB hold to A2. The example is, instead of glycinato, I found a research paper where I took this. This is a bidentate ligand having two different donors like glycinato. Phosphorus is one donor, arsenic is another donor. That is called Arphus. Arphus is the Arphus ligand is a bidentate ligand, AB type, is PH2, P, CH2, CH2, AS, PH2. Diphenyl phosphine, phosphine and diphenyl arsine. This is diphenyl phosphine. One diphenyl phosphino, two diphenyl arsino, ethane. So this is a donor, this is a donor. So that is like glycinato, BR are same. You find here this is cis, this cis, and the PP they are close. We start from here. PP are away, S are close. Just we make and it is disymmetric as a DL pair, and we just swapped, keeping we have swapped phosphorus with arsenic here and phosphorus with arsenic here. We found arsenic as arsenic opposite, phosphorus near. But this is again cis. And it is also disymmetric having a DL pair. Again, what we did, we swapped only one. We swapped phosphorus with arsenic here and did not swap this one. It is also arsenic. So cis has three forms and each of the forms are disymmetric. So, and the two trans, these two bidentate ligands are trans, so also bromine trans. But here we can swap phosphorus with arsenic so that we get another trans. So there are two trans 1, trans 2, and there are three cis, and each of them is optically active. So 5 plus 3, 8. 1, 2, 3, 4, 5. And these three are having their Judwa Behan like DL pair. So they are 5 plus 3, 8. So therefore, we have written in our notes today, we have written here that 5 plus 3, 8. We will not draw of the pictures henceforth. I have given, you can have a look. Whatever hi-fi I will be making today will be just for your curiosity, my curiosity and my excitement, and it will not be of any use in your examination for normal need purpose. Well, then this next type I will be telling you M, A, B, C, D and A2. This is glycinato, for example. This is another, say, different ligands like the one I have told you just now, and A2. If that is the case, there are 6 GIs and 4 cis, 2 trans. Here 3 cis, 2 trans. Here 4 cis, 2 trans. And all the 4 cis shows DL pair. So 4 plus 6 plus 4, 10 stereoisomers total. Have you written? I will show you now the example of A, B, C, D and A2. I written. These are just you forget. Written?
Yes, sir.
Now see. A, B, yes. Here A, B, C, D, A2 type. 6 plus 4, 10. I am showing you some example I have brought from, yes, A, B, C, D, A2. So this is sulfur oxygen ligand. Supposing this is a phosphorus nitrogen ligand. Forget about, there are so many ligands, we no, don't bother. I'm showing you there are two trans. The ligands, the bidentate ligands are trans, so also the chlorine trans. But by switching nitrogen phosphorus add in one, you will find here sulfur nitrogen opposite, here sulfurous phosphorus opposite. So that will give you another trans, but each of them will have a plane of symmetry, which is the horizontal plane, and therefore they are achiral. And all other cis, you will find there will be 4 cis, where the bidentate ligands are cis, but here PO facing NS are opposite. By making both switches, you will get NP SO. Now SO remaining constant, if you just make one switch between phosphorus nitrogen, you will get another. If you keep NP constant and make a switch of SO, you get another. If you make both the PN and SO switch, you get fourth one. So there will be 4 cis, each of which is chiral, symmetric. So this 4 to the 8 plus 2, 10, total 10 of this type. So then you need not have to draw any picture. It's not required at all. 18, I will be giving you another example. M A A2 BC. I have got this. Where AAA is like di-EN, diethylene triamine, all the nitrogen donors. We will not consider as ABA. If donors are same, we will consider as AAA. So this has 4 GIs, out of which pack, since there are 2 of same type, the moment you find either small a of 3 small a's, 3 small b's, 3 small c's, or capital A 3 times, then there will be pack. There will be pack, mer will come. There will be pack 2 and mer 2. And out of that, one pack is DL pair. So 4 plus 1, 5. Because both the packs are not disymmetric. One of the packs is disymmetric. I will show you the example. See here. A. Yeah, here. A2BC. And the example I got is rhenium, diethylene triamine, dibromido, chlorido, rhenium 3. It is a neutral complex. So one of the facial is chiral. Now I'm showing you the one which is chiral is nitrogen. Then you see NS2, CS2, CS2, NH, CS2, CS2, NS2. This is down. This is in one square position. This is the other square position. This is cis to this. This is cis to this. This is also cis. This nitrogen cis. All are cis. Now bromine and chlorine is here, and bromine is here. So that this has no chiral center. Sorry, there is no, it is disymmetric, and hence it exists as a DL pair. But the moment we switch between chlorine and bromine, this chlorine and bromine, then this there comes a symmetry element which makes this achiral. So you have to find out where is the symmetry element passing, and that makes this totally achiral. And here these are the 2 mers. Mers, why it is mer? Because this N, if you join the triangle, it is not passing through rhenium. But if you join this nitrogen to nitrogen is cis, this nitrogen cis, but this nitrogen to nitrogen is trans. So this is possible. In tridentate ligand, 2 terminal donors can be trans. It is a lengthy molecule. But adjacent donor atoms have to be cis. So when you make this type, This nitrogen, nitrogen, nitrogen plane is passing through rhenium. So this is more, this is more, this is more. So here only by swapping between bromine and chlorine, we have got this. This is another non-superimposable form. So both are mer, having this, having symmetrical achiral. These three are achiral. This is the only chiral. You can test. Let us not spend more time, otherwise we will be called as foolish fellows. So altogether 5. So I have written down here. So
ସେ ସେଟା A to B ହବ C ହବନି।
A to, yes, A to B, A to B. Thank you. A to B. So there will be 2 fact, 2 more, and so there will be additionally 1 enantiomer. So 4 plus, total will be 4 plus 1, 5. 4 plus 1 is equal to 5. Okay. Then we will write something else. That is (19) and make a underline here. The example that I will give you does not show any geometrical isomerism, only enantiomerism. That is a classic example, MAA whole 3 type. Write down no geometrical isomerism. Example is cobalt tris ethylene diamine cobalt 3 plus. Tris ethylene diamine cobalt 3 plus. So here you will find, we can draw AA, AA. It looks like as if this is symmetrical, achiral. But no, yeah, this one is going to the other side, and this lower one is going to the front side. So it looks in a planar structure, planar figure, it seems as if there is a plane of symmetry, but no, there is no plane of symmetry. This is achiral, and it has got its mirror image. There is no geometrical isomerism, there is no cis-trans isomerism, only its mirror image is non-superimposable, and hence it shows enantiotropism, not. So this is the mirror image here, this is the mirror image here, and this is the mirror image here. So this is DL pair, no geometrical isomerism. Similar is the case with MAA whole 2 and another BB. Similar, same D and L, no GI. Like cobalt ethylene diamine, bis ethylene diamine oxalato, cobalt 3. So that also you will not find any, because the two donors have to be cis. You can't make it trans. Supposing we keep, this is AA, this is AA, this is BB, and its mirror image will be DL. If you keep this, supposing you must be thinking, particularly Krishna might be thinking, supposing he makes, because he doesn't solve any problem, he creates problem, AA here and BB here, sorry, AA here, trans. Can we make BB in a trans manner? It's not possible at all. This configuration, this is not possible. So you have to make this. As a result, it doesn't show any geometrical isomerism. It shows only DL isomerism. Right? So we have completed. Before we make a table once again and revise, let me finish the other optical isomerism cases. This is the table we'll discuss after some time. After some time, we'll discuss. Square planar complexes, as I have told you, for simple tetramine, tetracyanido, when the ligands are simple, the planar complexes, square planar complexes do not show any optical activity. But, however, under some restricted condition, square planar complexes also show DL isomerism or enantiotropism. These are the three cases. Those cases are very, very rare, not for your examination purpose. Why shall I turn on the AI companion? What will happen? I do not know what is AI companion. Can anyone tell me what benefits shall I get if I turn on the AI companion? Yes, guys. So Vedank Bhatt, sir, does repulsion not possible? So I'm sorry, I could not see your chart at the time when you asked this question. About what, Vedank, you are asking? Repulsion not possible in which? Please write down in which example or which case you were expecting a repulsion. Please, I'll explain to you once again. Don't and feel free to ask me questions. So Girija, what is AI companion? I declined. You didn't answer. Now see, under one condition where the square planar complex will show optical activity is the use of chiral bidentate ligand. Supposing you are using a chiral bidentate ligand, like instead of taking simple glycine you are taking N-methyl, N-ethyl. Here is the chiral nitrogen atom. Had it been a normal nitrogen having three different groups, the pyramidal inversion is so rapid that chirality is never ever observed. But only when it is bound to a cyclic in a chelating complex, chelates, the pyramidal inversion is completely prohibited, and it's so optical isomerism like asymmetric carbon atom. So if this is D and its mirror image is L, I have not drawn. Case 2, some ligands which are achiral but very substituted, they also make the complex, although their donor atoms remain in one plane, as a whole the molecule goes out of plane and becomes dissymmetric, and in that peculiar situation it shows optical isomerism. This is for sake of fun we are reading. Don't be serious at all, and don't drag me to show you where is this, because you guys are really accepting Amlan, who is really focused to conceive things. Others, I'm sorry to tell. Otherwise, I would not have put to a trap yesterday for a simple thing, which was never the case before. Now see, here we have taken a bidentate ligand, which is achiral. The ligand is achiral, having substitution dimethyl here. In ethylene diamine, there is a substitution at the first carbon atom. And here, this is a stilbene diamine, or 1-phenyl, 1,2-diphenyl, 1,2-diamine, 1,2-diphenyl ethane, 1,2-diphenyl ethane, 1,2-diamine. So, and you have taken meso. Deliberately, you have taken meso. So, this is achiral, and once you prepare a complex, this portion will be square planar. But the other portion will make the molecule lack plane of symmetry. This will lack plane of symmetry, and this will have its mirror image form. Although it will be regarded as a square planar complex, but as a whole, the molecule is puckered, three-dimensional, lacking symmetry, disymmetric, and hence it exists as a DL pair. But had it been a tetrahedral, this is hypothetical, it is actually square planar. Had it been tetrahedral, then it would have, the angle would have been different, and there would have been a plane of symmetry in the molecule, and the whole molecule is achiral. But actually, they have, in the research, they have found DL pair. Therefore, it was proved that this portion is the donor portions, that is planar. But since this is sp3, this is sp3, this is sp3, this is sp3, the molecule as a whole is going out of the plane, and there is no plane of symmetry in the planar form, but there is a plane of symmetry in tetrahedral form, and hence, this is achiral, its mirror image is superimposable. So this is not a new form. This is D, this is L, but this is same. And the third case, when you take EDTA as ligand, but two of the ligands, carboxylate ion, they remain unutilized. It will act as a flexidented ligand. Out of its 6 donor atoms, the 2 neutral nitrogen donor atoms are used and 2 carboxylate donor atoms are used. The other 2 are remaining free. In that case, even if the donor atoms, the 4 donor atoms are planar, square planar, but the molecule becomes three-dimensional and lacks a plane of symmetry, is disymmetric, and exists as a DL pair. Tetrahedral complexes having 4 different ligands, they are very uncommon. And if you can prepare simple amine, aqua, and all that, most of the time you get square planar complex. We shall know the tricks and the theory. The reason behind coordination number 4 is very important, whether it is TD, tetrahedral, or square planar. We are going in a big way to distinguish between the geometry. How can we? But if at all you are working with all weak ligands, I'm just putting the term weak ligands, weak field ligands, you are getting a tetrahedral geometry, then it will be existing as a DL pair, which is extremely rare. So arsine complex of methyl, ethyl, sulfide, and benzoyl have been prepared, and the DL enantiomers have been separated, resolved. Otherwise, it is irresolvable. If there are small groups, then just like pyramidal inversion, it will be the flipping, the inversion between the two forms are so rapid, D and L form, it is impossible to separate D from L. But there are some new research that has been found out that these are called half sandwich or piano stool complex, where just like ferrocene, which is a dicyclopentadienyl iron 2, that is a real sandwich compound, sandwich complex. Here only cyclopentadienyl or dianide ion is there, only one, and that too, it is a monohaptic. There are 5 carbon atoms in ferrocene, all the 5 carbon atoms are involved simultaneously, but here only 1 carbon here is involved. So it is monohaptic, is acting as a monohaptic ligand, and there is a carbonyl. There are 2 carbonyl. This merely carbonyl, this is aceto triphenyl phosphine. This has been found to be in tetrahedral form, and they can easily resolve the racemic mixture DL form. So also NO instead of acetone, NO, they have been prepared. These are called piano, just like this is stand where you can keep your piano, and this is the stand. So piano stool or half sandwich complex have been prepared, which are tetrahedral, and they exist as a DL pair. And sometimes there is a, instead of a chiral center, you can have a chiral axis. For example, if you take a disymmetric bidentate ligand, AB type of bidentate ligand, take the case of BAC. BAC, not ACAC. Here is methyl and here is phenyl. And if you make two such, this is bis benzoyl acetonato beryllium 2 is a neutral complex. There, just like in biphenyl complexes, this ring and that ring remain perpendicular to each other. This plane can be a plane of symmetry or cannot be a plane of symmetry if there are two different groups. That is the case here. Here is phenyl and this is methyl. So one, if the two groups are same, at least in one they are same, then the other becomes the plane of symmetry. So that becomes achiral. But if both are different, phenyl, methyl, phenyl, methyl, and the biac, there will be two biac bidentate ligands that was found to be tetrahedral in shape, and DL pair was synthesized. And in some binuclear complexes also, with bridging ligands, they have found DL pair, meso. So they have succeeded to prepare the meso as well as a DL pair. So total, just like in two chiral centers, like tartaric acid remains in exactly tartaric acid kind of situation, where you get meso tartaric acid, DL, D tartaric acid, and L tartaric acid, RR, RS, RR and SS. They are enantiomers, while RS is meso. Similar type of situation here also they have found. So these are very uncommon in examination. So we will not bother about these cases. You can write down at your home these points about square planar complexes. Under three cases, they will show optical activity. The donor positions are square planar, but the molecule can go out of the plane and have dissymmetric in nature. So these are the three cases using chiral ligand, using such achiral ligand which will make force the molecule to go out of the plane outside and can have a dissymmetric situation or symmetrical situation. In case of tetrahedral, it is becoming chiral, but square planar it is becoming chiral, and also EDTA complex having flexi character. Tetrahedral complexes having four different groups are very rare, but they have been now prepared with PL enantiomers and which are resolvable. With this, let me try to show you and the table which you have already done. MA4B2 to none. A4BC to none. This is cis trans, cis trans. A3B3, tell me what are the names that you give? A3B3 type, what are the names you give? Yes, Amlan? A3B3, are you able to see my screen? Are you
Yes, sir.
able to?
Yes, sir.
So, what is the name? What is the name? Oh my God. See the copy and tell me what is the name given when
The
A3B3 type
Pacmer.
is FACMAR. At least Krishna, help me this time. FACMAR. People say cis trans, but we should say the correct thing, FACMAR. And if it's A3B2C, it has one FAC, two MERS. If there are three of one type, then FACMAR comes. FACMAR comes. So there is one FAC, two MERS. And if A3BCD type, this is the only case where you find chirality, that there is one FAC and three MERS. The FAC is optical active, so total is 5. So this is one. And then coming to A2B2CD, and starting from here, we go backward. Or from here, A2B2C2, how many diastereoisomers? 5. Out of which the cis is optically active, so altogether 6 stereoisomers. Ma2B2CD, as I was saying, that today I did like a student of your age, all the 15 of this in the Ballard's method, I reduced, I found 6. And out of which 2 of them are chiral, and hence 6 plus 2, 8. And in the similar manner, you can do MA2BCDE will be 9 plus 6, 15. ABCDEF will be 15 plus 15, 30. coming to next time, I will give you examples. Examples, not A, B, C, D, capital A, capital A. I will give you examples and I'll ask you how many total number of, how many diastereomers, how many enantiomeric pairs, and what is the total number of stereoisomers. And here then bidentate ligand of identical donors, ethylene diamine type, AA hold to A2, cis trans, cis is optically active. AA A2, AB, same, similar. Cis trans, cis is optically active. So 3, 3. And MAA A2B2, one cis, two trans. The cis is optically active. So 4. MAA A2BC, that is two cis, two trans. Both the cis, they are optically active. So 4 plus 2, 6. And MMA3B, the position where we got stock yesterday, and a simple solution could not come to your mind. Yes, it did come to the mind of Amlan, but he could not persist. He got little distracted. That teacher is not accepting what to do. I didn't dishonor your, I didn't accept. I didn't refuse also, reject also. So you were correct. A simple conception that was failing us yesterday. So that has no enantiomerism. So only Fack and Mer. 3 means Fack and Mer. Once you find 3, Fack and Mer. So there will be no enantiotropism. And AB, yes, each of the Fack and Mer is DL pair. So 2 plus 2, 4. Then this one, no, I have to make a change. We have done this one. See, have we done this one? AB hold to A2. We have done, right? What we have done? Not able to tell me anything. M AB hold to A2. We have done M AB hold to A2. Yes. This correction I have made 5 plus 3, 8. Right? But we have not done this one which I have written in the table, M AB hold to AB. Where 5 plus 3, 8, this is 6 plus 5, 11. So I have not put that capital AB hold to A2 in the table. And this is AA, where there is only optical isomers, not geometrical isomers, AA type, only 2 enantiomers, no geometrical isomers. So this, they are not important. So these are important. This, and this. These are important. And others are not important for your test. So now tell me before you go, I would like to ask questions. How many? GI, enantiomeric pair, total. Tell me, I will give you examples. So, tell me, how many?
202.
GI
202. No enantiotropism. Cis and trans. A4, B2 or A2, B4, they exist as cis and trans. No geometrical isomerism. Example कहुची तुम्हें कहबो. What is the name?
Packmer.
Packmer. A3, B3. This is A3, sorry. A3, B2C. देखो खाता देखो. Look to your table and tell me. Look to your table and tell me.
30. 30.
3 means what? How many?
1 fact 2 mer.
1 fact 2 mers. 3 means fact system will come. Fact mer. 3 means fact mer will come. So here, no, this is 4, sorry. Here, fact mer, 1 fact, 2 mer, so 2, and no geometrical isomerism. And supposing I will give an example, CO NS3 whole 3, a, what? ABC, H2O, Cl, Br plus Ma3
4 1.
ABC, Ma3,
4
sorry,
1.
A3 BCD, Ma3 BCD, small, sabu
Four.
small. So how many what? How many what?
4 1.
4
How
1.
many what?
1 fact 3 mer.
1 fact 3 mer. Key or Badki? Who is telling the answer?
Sir, Badki.
Very good. 1 fact 3 mers. But out of which, tell me what will be the condition here?
1 is just C star DL.
Which one is dissymmetric and objective? Which one?
Cis. Fact.
Is we are 21st century people. You are going back to 19th century. So the fact isomer, commonly people call this isomer is optical active. So total 5. So it is very important that you must be very thorough. And then coming to bidentate ligand, as we have studied, supposing we have, tell me how many?
2 0.
Are you kidding
2
me?
1.
Are you
2
kidding
1.
me? Look to your copy. A, capital A, whole 2, A2, small a2. C strands, but C is dissymmetric and exists as a DL pair. Yes or no?
Yes.
Sai.
Yes. Sir.
So 3. And coming to same thing, supposing I say CN, CL, BR. A, capital whole to A2, AB, small AB, same. 2, 1. Right? Tell me if I am doing something wrong, if I'm missing out something. Is it okay?
Yes, sir.
Supposing then I come to En, Cl2Br2 minus. I have to, because cobalt rarely goes above +3. So I have to make it an anionic complex. Doesn't matter. As long as the formula is capital A, small a2, small b2, we don't bother. So tell me. Look to the table.
3 1.
What 3? Here, there cannot be factor. There is no 3 anywhere. So there is 1 cis and how many trans?
2.
2 trans. So out of which is optical active, so +1. So 4. Yes or no? If you have any doubt,
Yes, sir.
you can check. This is M here. Here. MAA whole 2 A2. 2 GIs, sorry, MAA to B2. 1 6 and 2 strands. Cis is optically active. That is written in the OI page. I have made it green, therefore. So tell me, supposing I will give an example, COEN, I will make, this is Cl3Br. Or something we are missing. Something, 1 cis and 3 trans, in which case we got 2 cis and 2 trans. Yes, this is A2B2, but A2BC, 2 cis and 2 trans. I think we have done a mistake somewhere. Now, A2BC, that we have not considered. This I am taking the one which we failed yesterday because of Krishna. Now, Cl2Br, and supposing this is I. And this is a neutral complex, for example. So, how many? A2BC, capital A, then A2BC. How many?
3.
C? Huh? How many?
4.
Look to this. What? 2 cis and 2 trans. Are you following me? 2 cis and 2 trans. Koti tinta trans. Can you remind me? Koti tinta trans haithala. Tinta more haithala. We have already gone, right? A3 BCD. I think we have already done, right? Tinta trans haithala. Tinta more. Actually, tinta more. Trans no more. But how trans theta haithala and theta cis theta trans. So tell me once again. In capital A to B, C, how many? 4, out of which 2, what? 2 cis and
2 trans.
2 trans. And the 2 cis are optical active. So 2. So 4 plus 2, how much? 6. Then CO, EN, Cl3Br, the one which we are struggling. What? How many?
2,
Ready?
0.
What are the names? 3
Factmar.
One more.
Factmar. And no enantiotropism, we were struggling unnecessarily yesterday. Okay. Then coming to CO, Cl2, Br2, NH3 whole 2 minus. This is which type? Diamine, dibromido, dichlorido, cobaltate 3. Cobaltate 3. So it a formula. Which formula does it conform to? M?
A2B2C2.
A2B2C2. So how many GIs, diastereomers, how many
5,
enantiomeric
1.
pairs, so that the total number, yes,
5, 1.
yes, 5, 1. The cis, all cis that exists as a DL pair, total 6. And supposing I will just go the one which I was doing today,
Six, 2.
A2B2, A2B2CD. Yes,
6,
I
2.
was just trying to reduce the ABCDF 15. I reduced to how many when I not this one. Yeah, this one. How many?
6.
Your memory is very, very weak. Yes, Amlan?
6, 2.
6, 2, yes. 6, 2, 8. And if I make it CO, Cl2, NH3, H2O, NO2, and then Br. So it is again minus 1. Ma2, BCDE. BCDE. 4 are of different type, 2 are of same
9,
type.
6.
9, 6, 15. Aha, क्या हुआ? तेरा वादा. 15. And finally, if all are different, CL, BR, I, just doing it in a fictitious manner, I don't know whether this has been really prepared or not. In fact, out of these 15 plus 15, only 3 to 4 have been really synthesized. These are all hypothetically, predicted what could be the maximum number of diastereomers and how many of such diastereomers exist as enantiomeric pairs. So, 1, 2, 3, 4, 5, 6, supposing I will make it NO2. They're also minus. What?
15, 15.
15.
15, 15, 30. These are very important. And finally, before we leave, supposing I'll say this complex. Will it show geometrical isomerism, optical isomerism, both, or only geometrical isomerism? Only?
Both.
Yes, Amran?
Only optical.
Yes, ତମେ ଟିକେ ଖାଅ. Krishna, take some Jhandu Pancharist. ଥଣ୍ଡା ଦିନ ଆସିଗଲା. Take Jhandu Pancharist. Your memory power is going down. Yes, this AA whole 3 type that does not show any diastereotropism. Diastereomerism dekhe, that doesn't show. Only enantiotropism. There is no symmetry. It is disymmetric. So this is 0 and this is only 2. We have to write 2 here. Because since 1 was included here, we are adding 1 for the DL pair. But here there is nothing, for only DL, so we have to write 2 here, so only 2. That is the end of today's program. We have extensively studied. Any question? Vedank, are you still there? And we have seen how many, supposing I will ask another question. Finally, this question. Supposing CO, En, and H2O whole 4. How many isomers it will have?
Yeah, coordination number 5.
नहीं see 5 কেমতি হলাম এটা পরে En, are you kidding me?
Sorry, sir.
এটা 2, এটা 2 4 2 6, এইটা কোন দেখেইব ওটা সে লিস্ট রে নাহি, the one formula which is not belonging to the list 20 na 25 खंडे आमे लिस्ट करछे, आउ जोगुडा को मु देइछि सेगुडा को they are very less important. मु बहुत गुडा को देइछि जति कि मु लिस्ट करैली सेही थ्रू मैक्सिमम आईआईटी एडवांस रे मध्य आईआईटी एडवांस रे मध्य एति ग्रुप पाइबो तुम. And we will also solve problems. The last class I'll be taking all questions those have been set in complex compounds in All India Science Olympiad test, Chemistry Olympiad in class 12, 11, 12, as well as IIT Advanced, IIT Main. So, do you expect this? Neither it is NS2 whole 2, H2O whole 4. If this would have been the case, yes, cis trans only, no optical isomerism. A4 monodentate ligand. But this type of thing we have never encountered in our formula. So if that is the case, it doesn't show any stereoisomerism. So you can verify that. Supposing this is AA and all are identical, A. This capital A have to be kept in cis position. They cannot go trans. So in that case, could you get any geometrical isomerism? What you will do? Whatever change you make, you are not getting any stereoisomer. So this does not show any stereoisomerism. Okay?
Yes.
Yes, sir.
So
Yes,
the
sir.
one whose formula is not in our table, you presume, you be sure that that doesn't show any stereoisomerism. You can verify that also. So आज के लिए इतना ही. So we have to break for a long time. I mean about a week. After 13th, we will resume. The next will be the theories of metal ligand bonding. First VBT, then CFT, then MOT. Then comes stability of complexes, color properties. We shall be using some principle of collars from physics to find out the complementary color, which color you will expect, and solve problems. If it absorbs, its absorption peak is this, then what color the complex will show, that you can immediately predict. So, and then Jahn-Taylor theorem and its distortion in octahedral complex, stability of complexes, and so many different points we will be doing. And then metal carbonyls as a separate chapter, ferrocenes, metallocenes in general, and carbonyl complex where there is a p, p pi, d pi backbonding is a pi acceptor, sigma donor, so many things. I think I will be taking another minimum 6 to 7 lectures. So if you start from say 15, so by 2025 we'll be finishing that. So this will be my public program. After that, things will be very easy. We'll be discussing transition metals, all that. So that will not be a public program. Bye-bye. And those who are watching, so many guys are watching directly from the YouTube. So please let me know if you have any doubt or if you have liked it. Bye-bye.
Thank you,
Thank
sir.
you, sir.
Thank you,
अरे
sir.
रुह मत, थैंक यू. तुम्हें आज कहीं डेरी रे जॉइन कल मत पैफत दियो.